Hi kids, so in this video we'll continue with the sums from motion in one dimension exercise 2C from Concise Physics. We have already done till sum number 8. You can click on the I button and get the link. Let us see sum number 9. A car travels a distance of 100 meter with a constant acceleration and average velocity of 20 meter per second. The final velocity acquired by the car, the final velocity is V, is 25 meter per second. Find the initial velocity, which means U, and the acceleration of the car. First of all, the three equations of motions were V equals to U plus AT. Then we have S equals to UT plus half AT square. V square equals to U square plus 2AS. Now look carefully. Average velocity is given. Now we know average velocity is initial velocity plus final velocity divided by 2. So what is average velocity? 20. Initial we don't know. U means initial. Final velocity is 25 by 2. 2 multiplied by 20 becomes 40 equals to U plus 25. So U equals to 40 minus 25, 15 meter per second. So your initial velocity is 15 meter per second. Now they have told us to find acceleration. We'll use this relation because we don't know the time. So this relation will be suitable for us. See, V square equals to U square plus 2AS. V is how much? 25. So 25 square, this is 15. 15 square plus twice A. And S is how much? Distance is 100. Now just solve it. 25 square is 6, 2, 5. 15 square is 2, 2, 5 plus 200A. Now 625 minus 225 will give us 400 equals to 200A, which means A will be 400 by 200, that's 2 meter per second square, which means the acceleration of the car will be 2 meter per second square and the initial velocity will be 15 meter per second. Now let us see the next sum. Now look at sum number 10. What they have given, first write the information. When brakes are applied to the bus, the retardation produces 25 centimeter per second square. They have given retardation is 25 centimeter per second square. So first of all change it to SI unit, okay? 25 centimeter per second. Centimeter, how do you change to meter? You divide by 100, so that becomes 25 by 100 meter per second square. Again I'll read. When brakes are applied to the bus, the retardation produced is 25 centimeter per second square and the bus takes 20 seconds to stop, which means the final velocity is 0. The bus finally stops. Calculate the initial velocity and the distance traveled. Very easy. Look over here. V equals to U plus AT. Just be careful. A is acceleration over here. Retardation is given. So we'll just write negative. Okay. So V is 0. U we don't know. Over here we can write minus 25. Instead of A I can write minus 25 because retardation is 25. And T is what? T is 20. Remember, acceleration is negative of retardation. So this becomes, this is 25 by 100. So this becomes 1 time, 5 times, 5 times. So your 0 equals to U minus 5. So U equals to 5 meter per second. That's your initial velocity. Done. Now, distance. Now if you look carefully, we can use any one of the formula. I'm using this formula. V square equals to U square. Again, I'll write minus 2AS. Why minus? Because of retardation. So V is 0. U is 25 minus 2, 25 by 100. Negative sign I have given already. Retardation was 25 by 100. So acceleration will be, this was the formula actually. So instead of A I am writing minus 25 by 100. And S is how much? S we don't know. Let us calculate. This is 4 times, 2 times. So 0 equals to 25 minus S by 2, which means S by 2 is 25, which means S is how much? 15 meter, which means the distance traveled by the bus during this time will be 50 meter. Am I clear or not? Just be careful with this negative sign. This sign comes because of retardation. Okay? If you are using plus, then write, instead of A, you should write minus 25 by 100. It will come the same. Done. Now let us look at the next sum. Now look at number 11. Very interesting. What they have told us? A body moves from rest with a uniform acceleration and travels 270 meter in 3 seconds, which means the initial velocity was 0. The distance traveled is 270 meter in 3 seconds. What they have asked? Find the velocity of the body at 10 seconds after start, which means velocity they need after 10 seconds. See, the body is moving with uniform acceleration. So with these information, I can get the acceleration. See, S equals to ut plus half at square. Remember this? So S equals to u multiplied by t plus half a, we don't know. T square is 3 square. Instead of S also, we can put the value as 270. Solve it. So 270 is equal to, this is 9a by 2. So what is A? A will be 270 multiplied by 2 by 9. 2 goes up, 9 comes down, 9 3 times. So the acceleration is 60 meter per second square. We got the acceleration. Once we got the acceleration, we know that V equals to U plus AT. Just use the relation. V equals to U plus A. T is 10, which means V equals to 0 plus 600. That's 600 meter per second. That's the final velocity after 10 seconds from start. With these three information, we got acceleration. We use this in the second part. Done. Now let us look at the next one. Now look at sum number 12. Very interesting what they have told. A body moving with a constant acceleration travels the distance 3 meter and 8 meter respectively in 1 second and 2 seconds. So distance traveled is 3 meter in 1 second, and then distance traveled is 8 meter in 2 seconds. They've given. I'll just read. A body moving with a constant acceleration travels the distance 3 meter in 1 second and 8 meter in 2 seconds. Calculate the initial velocity. They've asked for u and the acceleration. Very easy. 2 cases. Look over here. We can write S equals to ut plus half at square. Instead of S, I can put 3. U, we don't know. T is 1 plus half a. T is again 1. So 3 equals to u. This is plus a by 2. This is my first relation. Look at this one. Again, S equals to ut plus half at square. I'll just substitute the value. So S is how much? 8 equals to U is how much? We don't know. T plus half a t square, which means 2 square. That's 8 equals to 2u plus this is 4a by 2, which means 8 equals to 2u plus 2a, isn't it? So we can write this as Take 2 common, so this becomes 4 equals to u plus a. Clear? Simultaneous equation. We can easily solve this now. Look over here, or just find the value of u over here. U equals to 4 minus a, and substitute over here. Substitution, simultaneous equation, you know. So 3 you can do by any method, elimination, cross multiplication, your choice. Instead of u, I can put 4 minus a plus a by 2, isn't it? So this is 3 minus 4 equals to minus a plus a by 2. Solve it. Minus 1 equals to 2 taken LCM minus a 2a minus 2a plus a. This becomes minus 2 equals to minus a, which means a equals to 2 meter per second square. We got a. We got 2 equations. Now you need to solve it simultaneously by any method. I've used substitution. Got the value of u over here and substituted over here. Now acceleration is 2 meter per second. Put it over here. You had u equals to 4 minus a. So u equals to 4 minus 2. So u equals to 2 meter per second. So initial velocity is 2 meter per second and acceleration is 2 meter per second square. Clear? Now let us look at the next one. Now look at number 30. Very interesting. A car travels with a uniform velocity of 25 meter per second for 5 seconds, which means the car travels, for 5 seconds with a uniform velocity. Uniform, the velocity does not change. Uniform velocity of 25 meter per second they have given. Okay. The brakes are at this point, after 5 seconds, the brakes are applied. The brakes are applied and the car is uniformly retarded. Of course, the car will retard. The velocity will decrease and comes to rest, which means finally the final velocity is 0. Finally, the body comes to rest in further 10 seconds. So it takes 10 seconds to come to rest. Find the distance which the car traveled before the brake is applied, which means in this region, the distance traveled. Before the brake is applied, what is the distance traveled? Number 1. Number 2, the retardation produced, and the distance traveled by the car after the brakes are applied. After the brakes are applied, which means for this 10 seconds, what is the distance traveled? This is distance traveled for first 5 seconds, you can say, before the brakes are applied, after brakes are applied, which means for 10 seconds, after brakes are applied. Now for the first one is very easy. Uniform velocity, 25 meter per second, time is 5 seconds. So distance will be what? Uniform velocity into time, simple, because the velocity is not changing, which means distance traveled before brakes are applied is 25 multiplied by 5. Distance equals to speed into time. That logic only. Am I clear or not? Because the velocity is not changing. So that's 125 meter we got. Number 2, the retardation produced. Now look carefully from this position to this position, suppose from here to here. If you look carefully, at this point the velocity of the body was 25 meter per second, which means the initial velocity for this region, for this 10 second, the initial velocity is 25 meter per second. The final velocity is 0. Time is 10. So we can use V equals to U plus AT. So V is how much? 0. U is how much? 25 plus A into 10, which means minus 25 equals to 10A, which means A equals to minus 2.5 meter per second square. And what does negative sign indicates? It indicates retardation, which means simply you can write retardation is 2.5 meter per second square. Done. Now they have asked the third portion, how much distance it travels after the brakes are applied. Very easy. We have the initial velocity, we have the time, we have retardation. Use this formula. See, number 3. S equals to ut. U is how much? 25. T is how much? 10. Plus half at square. A is what? Minus 2.5. Retardation, okay? T square. T is how much? 10. So 10 square. Now we just need to calculate this. This is 250 minus. This will be 2.5 into 100. 2.5 into 100 is 250. Divided by 2 is 125. So that's 125 meter. So before the brakes are applied, the distance traveled is 125. And after the brakes are applied, the distance traveled is still 125 meter. And the retardation produces 2.5 meter per second square. Remember this formula when you are using, you have to use a negative sign. Why? Because there is a retardation. For acceleration it's plus, for retardation is minus. Done. Now let us look at the next one. Now let us see number 14. Very interesting. A spacecraft flying in a straight course with a velocity of 75 km per second fires its rocket motor for 6 seconds. At the end of this time, its speed is 120 km per second in the same direction. See, try to understand. A spacecraft flying in the straight course with a velocity of 75 km per second fires its rocket motor for 6 seconds. So for 6 seconds, for time 6 seconds, it fires its rocket motor. At the end of this time, which means after the end of 6 seconds, its speed changes. Speed changes to 120 km per second. Okay. Find the spacecraft's average acceleration while the motor was firing. So while the motor was firing, which means we are talking about the first 6 seconds. I'll read one by one. This is the first part. The spacecraft's average acceleration while the motor was firing. While the motor was firing, time is 6 seconds. So we have V equals to U plus AT. Remember? Over here, the final velocity becomes 120 km per second. Initial was 75 km per second. So this is 120 equals to 75 plus A into 6. Be careful. So 120 minus 75, that's 45 equals to 6A. That's A equals to 45 by 6. 3 15s are 3 2 times. That's 7.5 km per second square. That's your acceleration. Done. This is your final velocity. This is your initial velocity. The time is 6 seconds. Now look carefully. Now the next part. What they have asked. The distance traveled by the spacecraft in the first 10 seconds after the rocket motor was started, the motor having been in action for only 6 seconds. So just be careful. Which means we need to find the distance for 10 seconds. Now we'll have two cases. We'll find distance d1 for first 6 seconds plus distance d2 for 4 seconds. After this 6 seconds, 4 seconds. Okay. Over here, the motor, it fires its rocket motor for 6 seconds. This scenario. Look over here. What is the distance? S equals to ut plus half at square. We can use it. Distance S equals to ut plus half at square. Am I clear or not? This is your d1 distance. S is distance. So u is how much? 75. T is how much? 6 plus half. A is how much? 7.5. T is how much? 6. 6 square is 36. So your S is how much? 6 5s are 30. 6 7s are 42. 45 plus, this is point goes away, 10 comes down, 2 5 times, 2 18 times, 5 1 time, 5 15 times, 2 1 time, 2 9 times. 15 into 9 is 135. I just calculated the value, okay? So S is 585 kilometer for the first 6 seconds. Now for the next 4 seconds is very easy. The speed of the body is 120. So distance will be what? Speed into time. That's 480 kilometer. So the total distance is 585 plus 480. That's 5 plus 6. 1065 kilometer. And that's the answer. Clear? For the first 6 seconds, you calculate the distance. For the next 4 seconds is speed into time. Simple. Because they have told it moves with a speed of 120 km per second. Done. Now let us look at the last sum number 50. Now look at number 50. A train starts from rest. A train starts from rest. And accelerates uniformly at a rate of 2 meter per second square for 10 seconds. For 10 seconds it accelerates. It then maintains, after this 10 seconds, it maintains a constant speed. Over here the speed is constant speed for 200 seconds. For the next 200 seconds the speed is constant. It then maintains, the brakes are then applied and the train is uniformly retarded and comes to rest in 50 seconds. So in the next 50 seconds, what happened? There is a retardation and the body comes to rest. Finally, the velocity is 0. There are 3 cases, First, 10 seconds accelerates, constant speed for the next 200 seconds, then retardation for the next 50 seconds and the body comes to rest. What they have asked, the maximum velocity, see the maximum velocity, the velocity increases. In this case what happened? The velocity increases, it maintains the same value, and then the velocity decreases, comes to 0, which means if we get the final velocity in the first case, that is the maximum velocity reached by the body. It reaches a velocity, it maintains and then decreases. Try to understand. Velocity increases, maintains and then decreases. This point, final velocity. So V equals to U plus 80. V equals to 0 plus 2 multiplied by 10. So V equals to 20 meter per second. And that's the maximum velocity reached by the body. Done. Then the retardation in the last 50 seconds. See, last 50 seconds retardation. The speed is constant. Over here the speed, the final velocity is 20 meter per second and it is maintained, which means at this point after 200 seconds also the velocity is 20 meter per second. So for this scenario, for the last 50 seconds, if you look carefully, the initial velocity is 20, the final velocity is 0, time is 50. So over here also V equals to U plus 80, V is 0, U is 20 plus A into 50. So minus 20 equals to 50A. So minus 2 by 5 equals to A. Negative sign denotes retardation, of course, which means retardation will be what? 2 by 5 meter per second square. Am I clear or not? Done. Now, they have given us 0.4 meter per second square. That's correct. The total distance traveled and the average velocity of the train. The total distance traveled, 3 cases, d1, d2, d3. Look over here. d1, how do you find? Over here, we can write s equals to ut plus half at square, isn't it? So s equals to u is what? 0 multiplied by 10 plus half. A is how much? A is 2. T square, which means 10 square. 10 square is 100. So s is 100 meter. d1. In this case, d2, if you find d2, the speed is constant. Time is 200, which means speed into time. Speed into time. So d2 will be, speed is how much? For this region, the speed was 20 meter per second. Time is 200. So d2 is 0, 0, 0, 4000 meter. d3, in this last case, d3, again I'm using s equals to ut plus half at square. Just be careful. S equals to u is 20, t is 50 plus half. A will be minus 2 by 5. Why negative sign? Because of retardation. Minus 2 by 5. T square, which means 50 square will be 2500. Just solve it. So it becomes S is, this is 1000. This becomes minus 500 after solving, which means S is 500. Which means total distance traveled, number third, total distance will be 100 plus 4000 plus 500, that is 4600 meter. That is the total distance traveled. Done. Very good. Now the last one, the average velocity. Now we know average velocity, average velocity is total distance by total time, which is 250 and 10, 260. Just simplify this. This is 230 by 30 meter per second. You change it to mixed fraction or decimal. Clear? See, this was important. Distance. We got the distance in 3 parts. The first part, s equals to ut plus half at square. Over here, the distance formula was speed into time because the speed is constant. Over here again, s equals to ut plus half at square, and a was negative. Why? Because there's a retardation. Okay. So in this video, keep it till here. At last, we have finished this chapter. This was the last sum from exercise 2C, Concise Physics, chapter 2, motion in one dimension. So if you like this video, do subscribe the channel. Till then, take care and be safe.